So my name is Arnaud Thiercelin. I'm the head of enterprise product for Auterion. I'm here to talk to you a little bit about the Auterion platform, especially in the context of enterprise users. So for those of you who have been keeping track, um, this is the last session of the day. So if you've missed the other ones that we've had, please come back tomorrow because we're going to be having them again. So very quickly, briefly going through what is Auterion and what we've been doing, what we're trying to do. So we're a Swiss-based company of 60 people strong, and we were built after the work that our founder has been starting on the PX4 side to basically continue it and give it a strong opportunity on the commercial aspect. And as such, we're still very much the biggest contributor to PX4. Which, if you're not familiar with, is a flight control stack that is powering more than 1 million vehicle. And we have, through the work that we've established, become the only standard mandated by the U.S. government. And so a lot of our work, and I'm going to be going through the presentation through it, is really about building that ecosystem for software-defined drones. So very much software-centric, from everything from the control, the payload, any third-party applications that you may need to, et cetera, et cetera. And so as a company, as I'm going to try to explain to you this, there is one place that understood very well what we've been doing, and that's Forbes, because they wrote this phenomenal article about us. And so if you haven't seen it, I very much encourage you to have a look at it, because it'll go into another dimension, and it's very enjoyable for us to be getting our message across and well understood this way. Now, the very real paradigm that I want to be pushing forward is that, I'm going to put my face in here so you guys see me, is that drones these days are 100% software defined. And that is that they're getting away from their very hardware focus, and the software becomes the very big element in the play that is very much defining what they're capable of doing. And we are very focused on that particular angle with a specific touch about the enterprise user. This is really what we're really building, our enterprise-ready applications using drone solutions. And we rally people around the label that we call Powered by Auterion, and through the presentation here, you'll see exactly what that means, but very much it's a solution that is using part of all of what our software stack is enabling them to do. And that's really what Powered by Auterion means. It's also a label for enterprise users to understand that if I have a Powered by Auterion vehicle in my hand, there's all of the other things that Auterion is doing that are going to be working with me. But as we're building enterprise applications, what it really means for us is to have drone components who are very much enabling enterprise customers in their rugged environment, which you want both a lot of the output of what the solution can build for you, and also a lot of simplicity in the usage, because at the end of the day, you're not really here to waste your time knowing how the tool works. The tool is here to work for you. But we're also very, very cognizant about the absolute essential importance of the scalability of the operations. We know that one drone has a lot of impact, 1,000 drones has even more impact. And we also understand the difficulties that come when you start scaling your operation from 1 to 1,000. And we're baking into our product elements that are removing this complexity. And so what the Auterion platform, what does it look like really? It's first and foremost 3 building blocks, and then their ability to interact with the rest of the infrastructure, yours, third-party application. And it very much starts with Auterion Enterprise PX4. And so very much like the flight control stack, Auterion Enterprise PX4 is our own modifications to it, while still contributing massively to the open source community. But it's also under that label that we are encompassing our whole avionics stacks, which is more than just a flight controller. We also have all sorts of services on the vehicle that are really working at simplifying, the use on a regular basis of these vehicles. And then after that, we have, user land applications, Auterion Mission Control, which is basically a ground control application that allows you to get all the control that you would want to expect out of the vehicle. And I should really say out of the vehicles, because Auterion Mission Control is capable of a one-to-many situation where the one pilot would be able to control multiple vehicles. In the end, deploying this kind of things very much depends on your local legislation body. And then after that, we have Auterion Suite, which is a complete infrastructure of cloud-based applications to manage your fleet from very much the moment they're being manufactured by an OEM or by a designer or a small shop, all the way into the end of the enterprise user that's going to be deploying these things on a regular basis, whether it's for themselves or as a service. We really have encompassed the whole scope of the pipeline, and even extending it all the way into extracting the information that are necessary out of the whole solution straight into the enterprise user data system, because we know this is where the actionable elements are happening. And so let's dive a little bit more about Enterprise PX4. So like I mentioned, Auterion was created on the previous work that was established by our co-founder, Lawrence. And he's really worked on that flight control stack that is PX4. And this is already where we have a huge expertise in that field, but it's not just in terms of the raw flight control element, it's also of everything that starts gravitating around it. And so Auterion Enterprise PX4 is first and foremost being able to control these vehicles. And I'm saying these vehicles because I'm counting multi-rotors, I'm counting VTOL, I'm even counting some odd ones that I won't be necessarily at liberty of talking about in here. But there's a huge amount of possibility in terms of what type of vehicle you can control. But this is also understanding the dynamics that come with controlling these vehicles that will translate into maintenance, which is being able to read through the data through a log about the different elements that are going to be meaning this vehicle requires servicing or not. This is also about understanding what element and how the whole avionics stack should be structured in architectures for safety and security. But this is even further than that. It's also a whole communication tool set that allows you to be able to talk to the ground control, talk to your suite, but also talk to other vehicles, and having all sorts of kind of weird or exotic communication schemes. Now, once you really have all this, and again, we're still very much evolving in the very necessary components of flying a vehicle, the next thing that we've incorporated is being able to talk to your payload and all of the different diversity and little features they have. You have very simple payload, a very simple RGB camera. You have payload with multiple sensors. You have payload with different kinds of approach. And as part of Auterion Enterprise PX4, we bring that management for you out of the box and very easily. And of course, there's the whole thick layer of the advanced autonomy, from collision avoidance, from collision rerouting as you're trying to avoid an obstacle, et cetera, et cetera. And it's a huge layer cake of behaviors that you would expect at this point from a vehicle, because again, the vehicle is here to almost fly itself for your need. And this is a great starting point, I want to say, although it starts to get a bit, but there's also that final layer where we are creating the entry points for you to be able to load your own app on the vehicle inside the mission computer. And I'll talk a little bit more about that in a second, because we know that you would want to be able to customize it for your own specific needs. Now, on the Auterion Mission Control, we call it AMC in short. This is really the land of what's in the hand of the user. You're here to understand and control everything that your vehicle is doing. And it is a completely feature-packed software that goes from real-time manual flying to mission planning ahead of time, right before executing, monitoring as it flies. You can even do it remotely through specific configurations and networking that we could go into maybe in the Q&A after that. And it really works on all platforms, so that if you want to be planning that mission on a nice, comfortable desktop, you can do that, save that mission, and then load it into your remote controller after the fact. There's a plethora of options that what AMC is offering for you that would fit your specific standing operating procedures. And then the last building block, but this is far from the last pillar of the Auterion platform, is very much the Auterion suite. And it's a little bit difficult to present the Auterion suite in the light that would give it justice, because there's such a huge amount of fleet manager out there. But the way I like to present it, a little bit, casually would be it's not your daddy's fleet manager. It's a complete command center. It goes way beyond the inventory management of knowing what vehicle I have at what location at what time. It has a very, very deep integration with both the data that comes from the flight controller, but also the dynamics of the vehicle, to the point that it's capable of providing you real understanding of the dynamics of the vehicle. There is a tight partnership with drone manufacturers so that they're capable of providing support by understanding how vehicles are behaving. There is a complete system that's also here to help developers with a cloud simulation system that you can just spin up on demand whenever you want, and so on and so forth. It's a place where things are going to continue growing, because it's really where we're absorbing a lot of the complexity of flying a drone at scale, and in the countless numbers and in the countless of iterations of sending them to the field, I would say. And so all these things together, they're already a good foundation, but they're really just a building block, but they're all here to very much provide you a new starting point, as an enterprise user, so that you don't really have to worry too much about the drone aspect of the drone solution. And then very much from the very edge of the vehicle that is capturing the data or is acting something on the world, to AMC to manage its operation through the suite and integrated it into your business, we really are building a complete end-to-end solution that is taking care of all the drone stuff out of the drone solution. But that was not enough. And so we went into the venture of trying to go even further by stepping into the hardware world a little bit, with a product that we call Skynode. And Skynode is a single board about this big, that allows you to control everything that you would need in terms of the avionics. It has a flight controller, it has a mission computer, and it has all the connectivity that you would want to. And it's, of course, tightly developed with all of our software stacks. So when something works on our environment, it works on Skynode, and vice versa. Something that works on Skynode is going to work on any other vehicle. And it takes care of pretty much everything. It has the proper payload integration, leveraging technical standards that we've developed. I'll talk about this in a second. It has the capacity of handling all sorts of sensors, including autonomy sensors, but also if you want to be doing precision positioning or things like this. It has an LTE modem integrated to it. It has Wi-Fi as well, and the ability to connect even more accessories to it. If you wanted to add another GPU to do intense computing on it, you could do that. If you wanted to add another radio system or your custom hardware to it, you could do that. And it is very much made not only to bring another solution out there, but very much to create a new standard and a new starting point for people to develop, simplifying the path toward the final solution of an end-to-end integrated enterprise solution. And so I kind of talked a little bit about these different things, but the work that we do is also very much about how we can take all of the things that were developed and bringing them straight back into the open source community. And it very much at many times it starts there, where we have an idea or something and we think, no, this actually belongs in the open source community. So we're going to stop and drive the development of technical standards. And on that front, there is some very, very interesting achievements that happened this year that I want to highlight. In collaborations with many partners, we pushed a payload management standard that is about to go public, we call the Pixel Payload Bus, which allows people to develop their own payload and with the understanding that it will be compatible with anybody else that is developing the standard. And this is an interesting standard because it's not only a mechanical connector, it's an electrical protocol as well, and a software protocol. So it's really a complete technical standards. There's also one around smart batteries that has been developed over the year. And we're continuing to be developing more. We're continuing on the communication layer and continuing in terms of the multiple vehicle communication, et cetera, et cetera. And this is a continuous ongoing effort that we drive and are very, very happy to see the result, because we see this as a clear element that opens countless doors for the drone industry. Now, I mentioned a little bit about integration without really going into the detail, and this is really what I'm going to be talking about now. It's early, but I'm happy to be the one that talks about this. But there's all these integrations, all of these means for people to communicate and integrate their applications. I want to be like bringing it like straight down. And the way they look like is what we call the Auterion platform SDK. We have very much three surfaces that we anticipate developers to be interested in developing applications for. So I'm going to start from, I would say maybe the most obvious one, which is the Cloud SDK. So Cloud SDK is very much the way to integrate your infrastructure to our platform. So the suite is going to create a lot of data, and you would want to be able to extract this information, including pictures, etc. And the Cloud SDK is providing you a lot of this information the way you would want to. But even go further than that, it goes into providing manufacturers the means to, once they're done with actually assembling the vehicle, generating its identity directly into the suite. So it's very much a two-way street, so that these vehicles can become automatically available into the suite. The Ground SDK is very much if you want to be developing your own ground system, your control applications that will go into the remote application, the remote controller, sorry. And this is very what you would be expecting, the typical things, mapping, etc. AMC is a great application, but we are fully expecting that customers will want to be customizing the application to integrate specific standard operating procedures as part of their pre-flight checklist, or they would want to be bringing specific intelligence straight into the hand of the user because it can be very valuable to have this validation directly. And the last piece I want to mention is about Air SDK. And Air SDK is currently the part that is getting the most attention as part of our interaction. And this is really the place where you're capable of creating an application that will talk to Auterion Enterprise PX4. And this is being able to control the vehicle, but also being able to talk to all the other service. And I'll give a few examples after that, consuming the video feed, processing it, and very much to create more autonomous behaviors out of the vehicle and out of the missions that you're running. And so with that, I'm going to be going through an actual end-to-end scenario in mapping and give you a little bit of insight on how all of the platform is actually showing up in the process. All right, so here we are on AMC on the desktop. We're preparing a mission, which is one way of doing it. You'll see in a second that there's another angle that we could do it. So you can use these little pivots. You have the automatic planning that is being calculated for you based on the pattern that you want. And now on the field, you take your drone out, and this one has a very bright sky note on it, ready to do the work. The usual work that you would go through as part of your pre-flight to make sure everything is going to work just like as you expected. And now this is the SkyNav, the remote controller that we've designed. And this is, like I was mentioning, you could do the exact same work that you did before, straight in your hands, directly on the field. You don't necessarily need to prepare your mission. It's just another approach to it. And there you go. The mission is being designed. The processor, the pre-flight checklist has been done on AMC. The vehicle is ready and it's taking off and going to do the work for you. So in this case, you're in a fully autonomous mission-based navigation, and the vehicle is going to follow the path that has been planned for it and take regular pictures as you would expect into any automated mapping mission. And in this case, the user is like monitoring the execution, making sure that things are going well. And we're uploading pictures in real time from the vehicle through Dropbox directly into the remote location. And so you can start looking at them in here. So this is a real-time application. You can already have an eye on how things are going, which is another dimension of validating the work is being done correctly. Now the drone has done the mission, comes back, lands, and then we'll do the data processing in a second. But like I mentioned before, our platform is very much not just one type of drone. We're capable of doing a similar kind of work with other vehicle, for instance, VTOL aircrafts. And this is a very, very interesting angle because the physical capabilities of the different types of vehicles are absolutely essential when you want to extract the maximum out of your solution. And at times, people have been trying to push multi-rotor too far. And so back in here on the suite, we have a real-time pushing of the logs. We can see exactly how things are going on. We can identify if a problem, you can be notified directly if something is going wrong with the vehicle as it happens. And of course, once you have collected all the picture, you can start stitching them together. In this case, we're using side scan to reconstruct the 3D imaging. And then we're back into what you would be expecting at a regular workflow. You're with your 3D data, you're going to start plotting around the element that you're interested in. And in this case, we want to be measure the volumetric size of that aggregate pile-in here. And so this is like, a pretty standard side scan, but this is really where we're getting where enterprise customers are very much interested. They want to get that final answer, which is how much aggregate do I have in here? And out of the picture that were collected automatically, we're capable of reconstructing it directly and getting access to that information. Yeah, so that's pretty cool. But I'm going to talk a little bit more about how we can extend this kind of scenarios even more. And so precisely talking about that, I want to cover a little bit about where are we taking Auterion from now on. And the first thing is going to be more enterprise-grade drones and more enterprise-grade parts. And what I mean by that is that we're a software company first and foremost, but we work with multiple partners and from the open source community and proprietary applications to really develop a whole plethora of options for users to find a tool that's going to fit their need the best as possible. And so, but this is I really want to kind of highlight about how this is about, really collaborating with people who are going to do the work by providing them like starting points, and also that open source technical standard. Then we're going to be really focusing on providing better developer technologies. And what I mean by this is not just SDKs, but also the tooling and the pipeline and the workflow that enables developers to be doing super fast iterations as they're trying to develop applications in the platform SDK I mentioned earlier. And the last piece is very much always integrating and baking inside the products that we create, the scalability and the need for integration. And what I mean by that is scalability is a bit of a word with no real meaning. Scalability in an enterprise setup really means being able to absorb the complexity that happens when you start having 1,000 drones. And the way it would translate is that having direct understanding on the sweet side that the battery number 2 of drone number 36 is in dire need of replacement because the way it had been discharging, we've realized that actually is a sign of early fatigue. And so instead of having a paper standard operating procedure that tells you, now this is going to be like 2,000 hours, I'm just going to be telling you right away, we're going to come to you to tell you, you don't need an SOP for this because we know these things, we keep track on how they're going on, and we're going to give you the means to handle this. Now, suddenly, when you want to be developing and deploying 1,000 drones doing this work, it's one more thing you don't have to worry about, one more step closer to the feasibility of the program. So this is really what we mean about scalability in this context. And when I'm talking about integration, we mentioned about the SDKs and how they allow you to build applications the way you need to. But this is really towards this one thing that you really want, which is the real answer to the question you're asking. And many times in drone solutions, we tend to really focus on the picture. And even in our demo, I'm showing you this 3D reconstruction. But the final ideal outcome is that you get that one number of that pile of aggregate with a level of trust that you never look at these pictures ever again, or they become even forensic data as you're trying to look into this. And this is really the work that we want to be doing. So out of the suite, you extract the pictures directly, but then we're capable of building partnership with people who are going to be digesting this data, bring their vertical expertise to the table so that it can extract the real information that this requires in action. And I'll give you an example. You're inspecting a wind turbine and you see an impact on the blade. What you really want is not see the picture of the impact. What you really want is an order for glass, fiberglass work next morning at the closest site that you have so that they can come and fix it. And what you'd like to be able to do is dive into the process that came to that conclusion just to make sure that this is right or for forensic need in case there was something wrong. And so this is really where we're taking the whole platform, which is towards basically absorbing more of the drone complexity out of the drone solution. And so I want to talk a couple more about, a couple of futuristic use cases. I'm going to put some quotes in here because these cases are really not 20 years down the line or even 5 years down the line. They're months away. And the first one I want to talk about is an AI-powered, fully autonomous search and rescue solution. And so what we're talking about in here is you're a search and rescue department, can be fire department, it doesn't really matter. But you have heard that there is a young boy with a red hoodie that has been gone missing in a park. It could be like a national park or something like that. So what you want in here is you want to take a VTOL aircraft that's going to be having the autonomy to fly long enough to cover huge areas. And I would even go even further than that. I would say you want to say multiple vehicles so you can cover the whole area. So from the suite side, you'll be able to plan the mission and divide and conquer to which areas each vehicle is supposed to be covering. Send this vehicle. As they fly, you have an application on board streaming the video feed from the camera and running a basic classifier on people with maybe a pre-trained model, so you can modify it with just the red component to it to increase the chances of detection. And you're going to be just sending them away. As they go BV loss, the stack on board the vehicle is just jumping progressively off the radio when it loses signal to the LTE signal and off to satellite radio, satellite signal in case you have lost the LTE as you're in a national park. The vehicle goes around, etc., and then at some point you have a detection. The vehicle changes its attitude. It's a VTOL aircraft, so you're trying to keep it in fixed wing mode and stop. Instead of continuing its scanning pattern, changes into an orbit, keeps an eye on the person, and then starts sending a message through satellite. The other vehicles are receiving it, returning to base on its own because the person has been found, and then the first responders are being alerted and they can just go straight to the location. Now, this is a real world scenario that is waiting for building blocks to be glued together. All the blocks I've been talking about, they do exist, and it's very much on us to be able to make it easy enough that someone is going to be building this scenario. This is, like I'm saying, it's months away practically as a technical solution rather than years away. And the second, a little bit more down to earth, which is going to piggyback a little bit on what I was mentioning before, is a little bit around that more practical scenario, but yet has a tremendous impact on the productivity of large companies or any companies of any size, is really being able to produce a real-time end-to-end workflow. And I'm going to use that wind turbine example again with that impact and that fiberglass work. Now, you can have a drone that flies autonomously around a wind turbine. This is pretty much yesterday's work. It can happen. It will work really well. And so once you take the pictures, what you would want is having onboard the vehicle in this scenario, a real-time processing of the images so you can check if they were taken correctly. So real-time quality control of the quality of the picture, make sure the features, the contrast and things like that are being done correctly. And then you could also expand this even further by starting to have a stitching or a pre-run of detections of anomalies that will come into it. Now, maybe you'll do a quick pre-pass, maybe an AI stack for classifications of known impact with a low threshold at a very low cost in terms of power, something that could run locally, but it would allow you to cherry pick which picture you would push up in the cloud. And then you would push that one picture that has a detection, that has a strong sign of a damage to it. Now you take this picture and you upload to the cloud where you're going to have inside the suite the ability of tying that mission, that vehicle, and the site that you've been doing to an actual project of an inspection. Get that picture processed directly and start analyzing if there's a real impact, and then continuing into what I was saying before. Run a proper classifier, analyzing not only that there is a damage, but analyzing what damage it is and what is the remedy for the damage. And then translating that damage into an actual work order into your ERP, your Dynamics, your NetSuite, your whatever. And by the time that you've landed, you're most likely 60, 80% down and having done what you really want out of the inspection, which is, what do I need to do about this site and when? So these are really the kind of futuristic case that we're focusing on building the elements to support. And we, like I said, these are not years away. They're months away in terms of practicality. It's very much about creating an environment that is easy enough and stable enough to stimulate that innovation. The last thing I want to talk about, because we talk a lot about software and architectures, etc., is I want to talk about something that we're very excited about, which is a drone that we worked with FreeFly. They designed and manufactured this this in the US with our software on board and Skynode on board. And this is the FreeFly Astro that you see right here. So they teased the vehicle. We think it's going to be an absolute killer. It's designed to work, designed to be the perfect enterprise companion. We're providing a lot of the software to really close that gap. FreeFly has done a phenomenal job designing and building this drone. And you'll get more information a little bit later in the month. And so if you're not doing this already, I'm very much inviting you to follow FreeFly on any social media of your choice. They're pretty much everywhere. This is going to be very, very interesting vehicle. And I don't even think that we can appreciate how much of an impact it's going to be. I really think it's a pivoting moment in the industry. And so with that, I'll leave it to your question and answers. Yeah, thank you. I'm seeing that Summing is answering pretty much all of them. So for more information about Skynode, you should reach out on the contact page that we have on auterion.com. And Summing on the chat can actually provide you with the link directly. I think I'm going to leave it on the slide about the Astro, if you don't mind, because it's just such a cool looking drone. All right, I'm going to give it one more minute. Feel free to ask question. So that's a very very interesting question about which safety features do you see emerging based on proposed coming regulations and UTM integration. Personally, the UTM conversation is something that I like to just wait and see where it's going. But I think type certification is probably the big element that we can talk about, that we're expecting, and we're actively involved in it. So for those of you who are not familiar with type certification is a way of for the authorities to really validate a vehicle, not necessarily based on an individual basis, like it's very much done in manned aviation, but really on a category of drones, and very validating what their software under control is, appreciating that this is the real big defining element to it. I think this is one that is getting a lot of buying everywhere and becoming very unanimous. Now, for the UTM, and I've seen different understanding about what UTM means for people, from the specific unmanned traffic management to navigating the airspace. Now, in the case of navigating the airspace, I don't, and I'm based in the US, so I don't want to be like talking for all the world because I'm from the engineering side of things more than the policy side of things. Um, but I don't think there is much more that would be coming up and expected. Maybe a standard around safety mechanisms like parachutes would be great, or safety standard around the necessary behavior for or the necessity to integrate ADS-B receivers to navigate manned aircraft seems to be a possibility. On the pure unmanned traffic management, there's a lot of experimentation that is going on, and this is why I don't want to be, being too decisive on one or another. But I've seen some project that people are trying to create basically unmanned vehicle highways in the sky. So defining section of the airspace that would be dedicated for traffic on unmanned vehicle. I think that project, like we're seeing with Zipline and Walmart working together, are going to be very interesting in shaping up and providing data for the whole conversation in terms of where this needs to be, especially for the context of BV loss, which is in phenomenal and untapped market. I could go further, but I think I'm going to start talking into too much hypothetical, so I'll leave it there. I think is going to be a very, very big deal, and precisely in the case of type certification. And I think that if we have a very successful outcome as an industry in terms of using simulation for type certification, we'll start seeing more use of simulation for other safety elements. I wouldn't be surprised, for instance, if the Part 107 evolves to have a practical test against the simulation. But this is completely speculative. So yeah, Sami was saying around comparing the Astro to a DJI, that would very much be like a same category in terms of size as an M200. But there is one fundamental difference that for me matters, and in my experience mattered to customer. I mean, don't get me wrong, the M200 is a phenomenal aircraft, but that flat profile that you have on an Astro means that all that space underneath it is very much an open canvas for all sorts of payload to be coming in. And I actually don't think that we've seen yet how far integrations and customization of this platform are going to be able to go, but that's exciting to see. Any other questions? All right, then I'll leave it here. Thank you very much for joining the presentation tonight, and I hope you have a great expo. Thank you.